ambiguity in grammar. So one example that we saw last class was used for the string and this grammar. So this is the grammar. So this is the grammar and the string. So for this particular grammar and string, so what is ambiguity? I'll be able to draw more than one parse tree for a single string. For a single string, using this grammar, I was able to draw these two parse trees. So first I started with a plus because my string had only plus operators. So I started with a plus. So I have three production rules. Okay, so these are the production rules. And first I prefer to expand the left part. Okay, so I expanded this E again with the E plus E. In the another parse tree, I prefer to expand the right part. So for the same string, ID is an identifier or a variable. So the same string or expression, ID plus ID plus ID, I got two parse trees because the grammar allowed me to. The grammar allowed me to construct two different parse trees. So there's nothing wrong in me constructing it according to the grammar. But when we consider the associativity or here there is no problem with precedence. When we consider the associativity, so plus operator has a left to right associativity. So this tree seems to the left derivation, the leftmost derivation seem to be the correct one, whereas the rightmost derivation is incorrect in terms of associativity. So my grammar shouldn't have allowed growth on the right side. My grammar should have restricted the construction of this parse tree itself. So I shouldn't have any ambiguity. My grammar shouldn't have allowed this. So what did I do? I tried to edit my grammar. So here I edit my grammar here. So what did I do? I restricted this right expansion. So I directly replaced it with a terminal. So there was no chance of expansion at the right side at all. So it did not allow me to expand at all. So I was allowed to expand only the left side. So I got the correct parse tree, a single parse tree for a single string. So this is how I reduced ambiguity. So remember, ambiguity is like when you are able to create multiple parse trees for a single string out of a grammar, the compiler will not accept it. Okay, so you have to reduce the ambiguity of the grammar. So you have to reduce the choices. Basically, when the number of choices is more, that is it tends to go in all directions. So you will get multiple parse trees. So depending upon the associativity or the precedence or how you want it, actually how you want the string to be evaluated, restrict choices or expansion. So that will help getting unambiguous grammar. Okay, so now we for the same grammar, we'll see another string with precedence. So with the string, this is a grammar, and the string we are going to see is ID plus ID asterisk ID. ID plus ID and asterisk ID. This is the string that we are going to see today. So we'll try to construct. So this using this unrestricted, we'll see why it's ambiguous, like we saw for the plus. So I can either expand it with E plus E. So it allows expansion of both plus first and asterisk first. Anything I can do. So I'll expand plus first. Then I'll expand asterisk next. E asterisk E. Okay. So this I'll directly substitute it with ID. This I'll substitute it with ID and ID. So how do we understand or traverse the parse tree? We traverse from the lowest height. So the deepest operator we try to visit first. So this is how. So it will be in this order. So it starts and it goes in this order, and then a plus. Okay. So it is in this order. Okay. So how do I write it? So first this asterisk is evaluated, and then so first this is evaluated and then it is added with this. So are there options, other options? Yes, this expansion is also possible according to my grammar. Okay, then I'll try to, since plus is before asterisk, I'll try to expand this and I can write a terminal ID. I can substitute ID. So in this case also, it will try to execute the lowest or deepest branch first. So this is E plus E is executed, and then it goes like this. So the same expression gets evaluated like this. So we have two parse trees and two types of evaluation for the same string with the same grammar. Okay, so this is ambiguity, and we all know that asterisk has a higher precedence. The precedence of asterisk is greater than plus. So higher precedence should be at the lowest level of the parse tree. So higher precedence operator should be at the lowest level of the parse tree, because you start reading or executing the parse tree from the lowest level. So highest precedence operator should be at the lowest level. So according to that, this tree is correct and this tree is wrong. So we can see in the expression wise also. So this has highest precedence. So asterisk should be evaluated first, and then addition should be done. So we have two ambiguous trees over here. So the parser is not able to decide which one it should be using. Okay, so it's not able to decide. It has the confusion. So we have to edit our grammar. So this is the ambiguity in our grammar. So we are going to edit our grammar to reduce ambiguity. So how are we going to edit? So we are going to restrict choices. That we are very clear. So we got two trees because we had two choices. I can expand either with a plus or with a. So how am I going to restrict choices? I'll introduce non-terminals. Okay, I'll introduce new variables or non-terminals. One for each precedence level. I'll introduce new variables for each precedence level. So I have two precedence levels here, plus and an asterisk. Okay, so I have a plus and I have an asterisk here. So I'll try to introduce new variables. So I'll say E tends to E, or instead of E, I'll replace it with another terminal T. Okay. Similarly, when I reach T, after I reach T, I can no longer do a plus. Okay. It should be, I'll do a T asterisk, another non-terminal for multiplication. So it is E plus T. For addition, I have introduced, for addition precedence, I've introduced a non-terminal. For multiplication, I've introduced a non-terminal. So once I've reached T, I make sure that I don't add anything else. I cannot add. Okay, I only can do multiplication. So F, I'll do ID. Okay, so this is not yet complete. We'll try to complete it. So after this, we'll try to draw. So E, I'll do a E plus and a T. I'll try to expand and see. Okay. In T, what I can do only multiplication. After I teach, I'm sorry, after I reach T, I cannot do a addition. So that's the purpose of the symbol T. Okay, symbol T is for plus and F is for multiplication. Okay, and after I get F, I can directly do a ID. But I want to reach ID from E and T also. Okay, so there are two ways of doing it. If you want to indirectly do it, we do it like this. Okay, so T reaches F, F reaches ID, E reaches T, T reaches F, F reaches ID. So these are called unnecessary unit productions. We'll remove, we'll further simplify. The same thing can be written like this also. E plus T or ID, T asterisk F or ID, right? And F ID. So the same tree, you can simplify and draw. Both are correct. It is not ambiguous. It is just like simplified, we say. So here I can directly replace an ID. Here I can say T asterisk F, and directly I can replace ID and ID. So it gets traversed in this direction. Okay, and so the associativity and the precedence is addressed. So the highest precedence operator should be at the lowest level. Okay, so highest precedence operator is at the lowest level. So both are correct. Okay, so this is like indirectly you have terminals in between, and then you reach the terminal, or directly you can write like this also, and you can substitute. Okay, so by editing the grammar, we have restricted the choices by introducing new variables or new non-terminals, and we have made the grammar to be more clear. no unambiguous. Like we've reduced all the confusion, we have restricted the choices, and we have made sure we have made sure that only one parse tree will be generated for this tree. Okay, so this is how